Las Vegas, once a small remote oasis in the Nevada desert, known for gambling, neon, and the Rat Pack. But today, Las Vegas wears a different face. The city now boasts 7 of the world's 10 largest hotels. It's a major convention location and one of the most popular tourist destinations in the country. Millions of people travel to Las Vegas each year, but not everybody is just visiting. The Las Vegas Valley is the nation's fastest growing area, at over 6% a year for the past decade. On average, 1 person moves in every hour. And as the city grows, so does the Las Vegas Valley Water District. Each new development project adds to the distribution system and the workload for district staff.
We receive 1,600 plans per month.
We receive anywhere between 60 and 80 projects a month of new construction, and that's subdivision, service connections, and large contracts. We as-built maybe 150, 160 miles of facility a year. We have 3,800 miles of pipeline, 75,000, 80,000 valves, 25,000 hydrants that we manage, 90,000 hard copy documents.
The district's engineering and resources departments work with developers on new construction, design distribution facilities, and provide drawings and maps to other departments within the district. In recent years, work has been pouring in, threatening to overwhelm staff. Something had to be done for the district to be able to keep ahead of growth. The answer? Going digital and automating some of the manual processes involved with developing, tracking, and distributing drawings and data. But first, they needed a better handle on their assets.
If you scan in chaos, all you've successfully done is transferred that hard copy chaos into electronic form. Really, in any document management system, the first thing is you need to organize your hard copy plans.
They chose a vertical filing system, saving space and consolidating drawings in one location. The system is more organized and more cost-effective.
This system has actually saved us from actually having to build a new building for plan storage. For instance, we had a plan vault that only fitted 14,000 plans in it. The multi-plan system has allowed us to fit 46,000 plans in that same floor space. Previous to that, we actually had plan cabinets going around corridors and in people's cubicles. It was very disorganized, and let alone trying to find a plan. Where do you go?
Once organized, drawings were scanned with a color scanner and assembled in a document management database. Barcodes are automatically assigned, allowing for reconciliation between digital and hard copy documents.
We found that we had 10% of our plans were duplicates between our digital plans to our hard copy plans. We found that we had 30% of our plans that were misnamed, and we found that we had 20% of our plans that were never scanned.
Now, digital files accurately and completely represent the hard copy masters, making the system easier to use and design drawings easier to find.
We can find a plan at the touch of our fingertips. There is no time wasted in trying to find plans. An average engineer spends 43 minutes looking for a plan and 10 minutes actually reading it. With our system, we can find it in seconds.
The system now contains nearly 200,000 digital images, but design drawings only account for part of the district's digital assets. As the system has grown, data from the document management system has been combined with data from GIS applications. It's a departure from traditional data management, but combining CAD and GIS is not as difficult as it seems.
CAD technology and GIS technology are really built on the same spatial infrastructure. They're in many ways very similar. CAD is a wonderful tool for doing engineering work, and it's also a wonderful tool for doing data content and data conversion. The GIS side is much better at mass production, mass producing maps, doing central data management, ensuring that the network topology is solid and correct. And we built systems so that our CAD technology can manage and edit that data.
The CAD group still works with design drawings, and the GIS group still creates maps, but the processes now share data. The combined systems allow users to correlate between design drawings and GIS data, resulting in more powerful and more efficient quality assurance. It also combines an abundance of data in one location. Digital assets can be searched through the GIS database.
So what we did was we built the design of the system so it interacted with the district's engineering database management system and its customer information system, its CIS system, and integrated that information so someone could click on a parcel and get all the customer information and the meter and where it's located and when it was last serviced, or click on a pipe and find out its installation date and its material and diameter, for instance.
The next step was to automate input into the system. Applications were designed to create digital versions of plans as they are developed and post them to the document management application. Through the lifespan of the document, it is modified and added to through document management and database fields.
The whole goal really was to enter data once and have that migrate through all our processes and work on producing products and less on managing data. There's no reason why you have a GIS guy adding data that the CAD guy added, at the beginning of a project.
By moving data back and forth between groups automatically, modifications become well-tracked, smoother, and can be applied universally, saving time and preventing mistakes. The data was now well-organized, dynamic, and useful, but it also needed to be accessible.
We built systems that deliver those to the field. One is an application called FactField, which is a web-based delivery tool that people access wirelessly through CDMA communications. The other is our application called FieldRDV, which is a tool that maintains documents, all our maps and all our drawings on laptops for field use. And we hook them together.
Having accurate information directly accessible from the field makes jobs easier and more efficient. The first group to use the new technology was line locators.
A locator traditionally had to, while he was in the yard here, he had to go and pull up record drawings, try to guess how many he needed. Most of the time we would err on the side of caution. With the database we have now and the application facility view, we can drive directly to the site. The maps and drawings for our projects are on the laptop computer. He has a dynamic link back to our yard. He can actually access our facilities without having to come into the yard. He has more data and a lot less time spent obtaining it.
Field crews can use a wireless laptop computer to search the engineering database for GIS information. Search results and job tickets are transmitted wirelessly, but linked to maps and drawings stored locally on the laptop. Line locators now handle nearly twice as many tickets as they could just 4 years ago. Soon, distribution crews were calling on line locators to assist with facility locations for repairs. Another group was ready to implement the system.
In the old days, we were required to take out 2 or 3 map books. We had a lot of paper that we had to take out in the field to have an understanding of where our valves were located in order to make a shutdown. With the computers, we're able to shut down our system quicker. It allows us to know where our valves are, where our mains are, and whatever we need to do, we have the information available.
The information is easier to find and use. It's also more accurate, critical for field crews.
Before putting the computer system in place, we did everything on paper, and the information just wasn't updated. So we would go out and shut the wrong valves and have our customers out of water, have customers out of water who should not have been out of water. Now having the computer system in place, we're able to go down and shut the correct valves, get our customers back in water sooner after making the repairs. And if we didn't have the computers, we would be lost. I mean, we just wouldn't have the information in the field.
Field crews had better access to more current information. However, with such rapid growth, information wasn't being produced fast enough. Crews needed access to redline drawings and as-builts sooner.
The redline drawings indicate new mains that have been put in the ground. And if we don't know where those mains are, if we don't know where those valves are, we won't be able to have control of our system, and we need control of our system.
New projects are now surveyed with a GPS unit at the same time as the inspection. GPS points are combined with approved facility design data, and digital red lines are automatically generated. It's an extra step, but it saves time.
The actual red line process has actually saved our inspectors 60% of their time. They no longer have to actually draw as-builts. Our automated red line process actually generates the red lines directly from the GPS data. It automatically calculates all of the ground dimensions and provides all of the call-out information. We no longer need an inspector to do a tie-down from a valve to back a curve because we calculate those all from the GPS points.
Geographic data is available days sooner and is much more accurate. Pipes and fixtures are now surveyed to within 2 centimeters.
People are now relying on our stuff to do their work. You know, if they have to dig up a street and you're 10 feet off, I mean, it's very expensive. If a contractor is using our plans and hits one of our pipes and causes $60,000 worth of damage, whose fault is that?
Combining original drawings with GPS surveys also provides an extra layer of protection against mistakes made in the field, which may have been missed in the inspection.
We've ran into one situation where the inspection GPS crew went out and GPSed the fittings and pipe alignments of a particular project. And when we mapped it and created the field markup drawing, you could see that it was off from the original design by a substantial amount. And we ended up having to communicate that both with engineering services and development services to see what action we should take. But we also brought it to the developer, who could see clearly the mistakes that were done, and they were then addressed out in the field.
Once red lines have been checked and approved, as-builts are automatically generated. After a quick quality check, final as-built drawings are available enterprise-wide.
The following day, we have that data in our database. Our field crews are able to access these GPS points in the field in their trucks.
There is a saying in Las Vegas, if you can't find what you're looking for, just wait. It's probably already under construction. By building database applications, the Las Vegas Valley Water District has developed greater control over and easier access to information.
Bottom line, more accurate data, faster data to the field, drawings that are far superior to what we had in the past.
It not only helps them stay ahead of rapid growth, it helps improve service throughout the organization.
Whether it's our distribution crews in the field that are actually fixing a line break, our line locators that are actually line locating where our facilities are, to our design section that is actually designing future facilities, our information is critical to all of those people for the successful operation of the district.
It makes everyone more effective because they need to see what's built in order to do planning, in order to do design, in order to do construction, and ultimately in order to maintain and operate facilities in a more effective manner.